Welcome back, guys. Today in this video series we are going to see the what are the basic type of the signals based on the graphical view. As previously said, we are taking the two-dimensional view, and one is we named as time, and one is we named it as the amplitude. Based on the amplitude and time, there is maybe the y-axis may be continuous or discrete. At the same time, the time axis may be continuous or discrete time. There are different way to plot the graphs, but how can we differentiate it? How continuous, how these are differentiated, how can we answer these questions? So here I am going to show you the 4 pictures, and you let's answer yourself. How can you say these are the continuous amplitude and the discrete amplitude, right? Let's see the first diagram. Here we can see the continuous amplitude and continuous time. It's simply it is like one kind of the continuous sine waves. Mostly we are dealing with this kind of waves. So that means continuous time means I can give the two different statements of for y-axis as well as the x-axis. Then you can easily say that this is continuous amplitude or discrete amplitude. So first of all, let's see the continuous time. For suppose it's continuous time or discrete time, how can we say that at each and every point, if you are able to tell what is the amplitude at that point, that kind of signals we can say continuous time, where the signal is defined only some particular parts of the time. That kind of axis we can call it as a discrete time axis. For example, see here in picture 2, see at particular time, for suppose if you just name it now, just give some numbers to it, 0, 1, 2, 3. I think this color is now good. Let me change. 1, 2, 3. So if you ask the questions, what is the amplitude of the 1? This is the amplitude, right? It is not clear. That means you are unable to say this will be the amplitude of that signal. So such kind of sharp variation if you see in your signal, then we can say these are the discrete time. Because don't confuse it with amplitudes. I will give some separate statements for continuous amplitudes and discrete amplitudes. So just take the continuous amplitude. So if you see any sudden change in the amplitude at particular time, that kind of signals we can say discrete time. Otherwise the signal is not defined for a particular duration of the time, then also we can say these signals are discrete. For suppose I given examples like, if I ask this, after seeing that, so you can say this is a discrete, not discrete time, it is a continuous time, because the signal is continuous. But where I can call as a disk, even at let's say 1, 2, at 1 and 2 the signal value is 0. Here if you see the picture 2, here also at 1 and 2 the signal value is 0, but at some particular points you are unable to say what is the amplitude of the signal. So that kind of situations we can say it is a discrete time. The continuous time is these are the at each and every point we are able to tell this is the amplitude. That kind of axis we can call as a continuous axis. Discreteness we are unable to say what is the amplitude at particular point. That kind of signals we can call it as a discrete axis. Now let's come with continuous axis, y-axis. This is continuous or discrete. How can you say continuous and axis? This is a very difficult type of the questions. Let's say let's say that if you give the let's say some distance signal. If you see the any sharp edges at particular point, that kind of sharp edges we can call it as a discrete amplitude. That means if you see the sharp edge in any graph, that is discrete in time, discrete in amplitude. So this kind of amplitude shifts, if directly this is a discrete amplitude. But let's say if I give like this, like the signals, and if one come and ask the what is the type of the signal is continuous amplitude or discrete amplitude, but the answer is unknown. The answer is unknown. No one can answer these questions because let me explain this situation with the one practical example why we are unable to say that is it continuous amplitude or discrete amplitude. One thing is clear, the time is discrete definitely, but the amplitude is if you see the sudden change in the amplitude, but no one can answer directly is it continuous amplitude or discrete amplitude. Why means let's see one practical example how we are converting some digital signal into let's see how we are converting some analog signal into digital signal. These are the basic blocks. We are giving some continuous time, continuous amplitude signal, and we are passing this to low pass filter to limit the bandwidth. After that sampling, we are that we are passing this to the sampler. The sampler, what it will do, it will sample at particular time of the time. That means this signal will be sampled. Let's say this is sampled at these points, right? That means the axis become the discrete. The time axis become discrete. Let's see. Discrete means at each and every time the amplitude is not defined, so the axis become the continuous. But whatever the amplitude is continuous, it is not discrete. Why I am saying discrete means even if you see these pictures, yeah, like this. But how can I say that there is a short pitch here also? But how can I say that this is the continuous amplitude means? In continuous amplitude, there is some different definitions are existed. Let's say my signal amplitude are existed from 0 to 3 volts. I have some continuous signals. So I send this. So I send the signal to the sampler. Let's say sample is equal sample for every ts seconds. I am sampling the signal. So I will get like signals like this. Some kind of samples again. Do you anyone predict what is the amplitude of this? Means it definitely in the 0 and 3 volts. But no one say that particular value of that amplitude, because we don't know, depending upon what kind of signal variation is presented input of the sampler. Depending upon that, the sampler will just sample the particular value. Maybe this value may be 0 to some amplitude 3. It may be any value, maybe 1.2 volts or 1.0002 volts. That is undefined. Depending upon the input signal, the amplitude decided. So according to this scenario, we are naming this as amplitudes are always continuous if any values get presented. Then same sequence. So here I am saying continuous. Once if I pass this continuous signal through quantizer, the output also I will get the same kind of wave. Maybe amplitudes maybe get different. Such kind of wave now I am calling it as a discrete amplitude. Why I am calling the discrete amplitude? Previously by looking the graphs both are looking same, but now why I am calling this kind of graph as a discrete amplitude means what actual quantizer is doing means the quantizer is round offing the value. For suppose let's say some step size is 1 volt. Please don't worry about this step size. When we are going to further lectures, we are going to go the step size. That means step size is what it means. The output will be round to near to the 1 volts because 1.7 volts is presented. So the quantizer what it will do means the whole value get rounded to 1 volt. Suppose 2.3 volts means it may be around to 3 volt. That is depending upon the how quantizer is designed, but it is going to round off to some particular value. So after quantizer, if I ask what is the voltage run, we will definitely say that that may be 1 volt, 2 volt, 3 volt. Like that, we are the whole amplitude must be fall under the some range of the values, particular values, that all values are in my sample space. So if you able to tell the what is the amplitude range, not range, the some digital values, some sample space values. For example, my sample space 1, 2, 3, some 3.5, like that. If my amplitude is fall under these values, not range, in this value, particular value, then I can say this is the continuous amplitude. So if anybody is asked, if you give such kind of graphs, if anybody is asked what is the type of signal it is discrete amplitude or continuous amplitude, but the answer is 50% probability. Just throwing a tossing it coin and ask the will it turn head or not, like such kind of questions nobody is asking. Maybe where you are seeing this situation, if you seeing this signal before the quantizer, it is a continuous amplitude. If you seeing same signal after the quantizer, it is a discrete amplitude. So I think you get the clear idea what is the discrete amplitude and the continuous amplitude signals. Thank you. We will see in some standard circuit in the next lectures. Thank you for watching.